Hey everyone, welcome to Tiffany Talks Telemetry. I'm your host, Tiffany. As a solutions consultant here with Harris in the Twin Cities, it's my job to help building owners and managers operate their facility as efficiently as possible. And over the years, the way we monitor and maintain buildings has changed, so I'm here to share the exciting news around it. Stay tuned and get ready for a new episode of Tiffany Talks Telemetry. Welcome to episode 1 of Tiffany Talks Telemetry. Today, our guests are Michel Michno and Bob Swanger. Michel is currently the CEO at Harris and has been with us here for 6.5 years. Previously, Michel had spent 30 plus years of diverse experience in the facade and ornamental metals industry, having served in an executive capacity for several leading companies. At Enclose Corp, he led the development and implementation of advanced design and engineering systems, positioning the company as an industry leader. Bob Swanger is the Executive Vice President of Service and Building Automation. Bob has been with Harris for almost 10 years. He has over 30 years experience in the sales, operations, management, and leadership in the B2B service and building automation industry. He's an executive leader that believes success comes from building great teams by challenging the status quo, collaborating, and having a relentless work ethic. Well, hello and welcome to our very first podcast. Thank you both for taking the time to join me today. I'd like to jump right in, being that it is our first podcast, and start with the history of telemetry. So, Bob, could you start with telling us a little bit about the history and how it all came about?
So, telemetry really started as an idea that for the last probably 10 years, I've been watching the trends of how people are using analytics to improve the way they operate, maintain, repair equipment. And I think a great way to think of it is, if you just think of something we all know, which is your car. You know, and 15 years ago, when you got your car and you drove it 3,000 miles, and you went to Jiffy Lube and you went in and you got your oil change and they put a little sticker in the window, and you knew that 3,000 miles or so many days later, you had to go back in and do it again. And nobody does that anymore, because the cars have sensors in the engine. They're looking at the oil, they're looking at how you drive, and they're using an algorithm to predict when should you change your oil for optimal fuel efficiency and to prolong the life of the equipment and to make it run better. And that's really what we're trying to do. And that was really the idea. We knew that buildings were collecting millions and millions of points of data every single day, every minute, every hour in buildings, and most people were doing nothing with it. And it gets overwritten. So if you think of an average building, there's thousands of sensors in the building, and the building's collecting this data, and it's going in. It's being used to make complex decisions about how to control the temperature and humidity and the ventilation rates in the building, and that's all great. And sometimes making it more energy efficient, that's all great. But the challenge becomes that where does the data go? And the data goes nowhere, because it goes into this controller in the building. And in most buildings, there's a few exceptions where they back it up. Most buildings, it just gets overwritten every 4 or 5 days because it runs out of memory and it starts recording the new data. And it just gets overwritten, and the data just vanishes and goes nowhere. They do nothing with it to help optimize the building or figure out what's the optimal maintenance schedule, or are there trends of how the building's getting better. So that's really across the broad spectrum how we got the idea and said, there's got to be a better way than just going out every 3 months and changing air filters, or going in and doing an expensive recommissioning effort in a building, and then watching the building, we take it from inefficient to being really efficient, and then over time it just drops off again. And then several years later they go, oh, we're inefficient again, now we should go in and we should make it more efficient again. And then they spend a bunch of money and they go into this one-time event and they feel good about themselves, and then they drops off over time. So that was what we were trying to avoid, or where that was really the idea behind what we wanted to accomplish.
Right, being more efficient and also more predictive with the maintenance too.
Yes.
Gotcha, good. So Michel, how did Bob first introduce you to the idea, and what were your initial thoughts?
It was one of those ideas that started in water cooler conversation. It was not a formal presentation. It aligned with some of the things that actually I had learned about the business at the time. I hadn't been at Harris for very long, and it's something I ended up understanding is actually how complex mechanical systems are, and how difficult it is to really get a perfect result in all situations. Especially as soon as you start dealing with multiple rooms and buildings of any size, things happen that are not necessarily intended. And when the analogy here, for example, when Bob was talking about measurements, is are you measuring the right thing, or are you reporting on the right thing? It's just like if you continue to use the car, are you measuring how fast the wheel is spinning? But what does that tell you? You want to know how fast you're going. Mm-hmm. And really, most of the industry was really looking at discrete components of mechanical systems and measuring how each one of them were doing. So you're measuring what the wheel is doing and the steering wheel and these kind of things. But at the end of the day, what does the driver care about? What does the building owner or the person using the facilities, what do they care about? And this system enables us to actually do just that. Is it, what do you want your building to do? And is it actually doing that? And telling you that real time. So that was really exciting. We jumped on the idea right away and proceeded with it.
So was it a pretty easy decision then when Harris decided to invest in developing the idea, or was it pretty difficult?
Well, it was an easy decision to say every indicator in the industry, every trend points to the fact that this is where the world was headed. Mm-hmm. And the people that get there first, the companies that get there first, are going to have an advantage, a first mover advantage. But it wasn't an easy decision in respect of saying, it wasn't like I went to Harris and Michel and Greg at the time. It's not like they said, okay, here's a couple $1 million, go figure this out. Right. They said, hey, this is a really great idea. Make it work within your budget, but you still owe us the plan you said. So we essentially bootstrapped it through the service team, and we co-opted the building automation teams to work with us. And we kind of did it, mm-hmm. but it wasn't like we had a grand vision at first. We knew where we wanted to get, and in the spirit of whether you call it skunk works or bootstrapping or whatever you want to call it, we just began doing it, knowing that this was the right thing to do and self-financing it through the way our business is performed.
Mm-hmm. So with significant investments made into telemetry, what does that mean for Harris, and what is the overall strategy behind it?
Well, it completely aligns with our vision and purpose. It is trusted partner, and at the end of the day, we design, we build, we service, and we plan how our systems are going to operate for building owners. And are we actually doing it? And with this system, we can actually tell our customers, this is what we said we would do, and it is actually doing it. Mm-hmm. And it allows us to even do quality control on projects. When you have millions of parts on the building, it's very easy to install something backwards, one little valve, and you wouldn't even know about it unless you had a system like this. And so people can trust that what they're getting from Harris is what we said we would deliver. And that's very important to us. That's the type of relationship we want to maintain with our customers. And so strategically, it totally aligns with where we want to go and why we exist.
Yeah. So we've made these investments and we have an overall vision of the strategy. What would you say is really in it for our customers, and how does it help them?
Well, I think it's part of what Michel just said, which is a lot of times customers, so if you think about how buildings come together, somebody decides to build a building and they find a piece of property and they hire a developer and an architect and they develop the property and they develop what the building's going to look like, and they hire a mechanical engineer, and the mechanical engineer designs a mechanical system, and then they hire a general contractor to actually build everything, and they hire electricians and mechanical contractors and all these other building trades to come together, and they put this building together. And usually they have a commissioning agent, and the commissioning agent maybe comes in near the end of the completion of the project. And the commissioning agent comes in and they go, okay, we're going to test this building, but it's not occupied. There's nobody working in it. It's like maybe it's a 2-week window, and whether that 2 weeks is in February or July or October makes an enormous difference. So they get done and they say, yep, we can promise you, we've commissioned the building. This building performs exactly as specified, given that there's nobody in the building and it's this span of temperature and outdoor conditions. But we don't live in that static world. We live in a dynamic world. So what happens immediately upon people come in, all of a sudden everybody moves into the office and they start moving stuff around, and they decide they don't want to use that conference room for what they had planned, or they're going to put an office over here, and all of a sudden everybody has their laptops turned on, and then they have their personal iPad so they can shop at Amazon while they're at work, and all these other things that they're doing, right? That, and they have cell phones plugged in, and it's a little chilly in this part, so they plug a unit heater in underneath the desk over here, and all these strange things start to happen. And on top of that, the dynamic conditions outside are changing every single day. We're in Minnesota. What's the famous line? If you don't like the weather, just give it a few hours, it'll change, right? I mean, it's going to be completely different. It can be, there's times of the year here where it can be 0 degrees in the morning and it can be 50 degrees in the afternoon, or it could be 50 degrees in the morning and it could be 100 degrees in the afternoon. And so those conditions change really dramatically. How does the system perform under all of those dynamic circumstances? And what telemetry allows us to do in a new system is it allows us to look at that through what we call performance-based commissioning. And we can look at how the building performs every single day. We can see how each individual piece of equipment, and how it scores. We have a unique scoring system we use for every piece of equipment. We consolidate those scores into a building score, and we can look at how it performs under different conditions. And when things are degrading or changing, we can come in and we can continue to fine-tune that system based upon how they use the building, how they occupy the building, and what the outdoor conditions become. That's how we know that you're getting a really good system when you have Harris on your team doing this work.
Yeah.
I could add that it's switching from a static environment to a dynamic environment. So now we can actually either anticipate or react to changing conditions, where the entire regular process of completing a building is fairly static, as you said. You deliver that building on that day, and it is doing what it was designed to do, and you're done.
Yep.
And that's not the end of a useful life of a building. You're going to have to be there for another 50 or 100 years.
And I think Michel said it well. Earlier he said there are times when things get done wrong, right? Something just gets installed incorrectly. We have seen people install pitot pickup tubes backwards, and gives you really funny results. We've seen things get left in a hand operating position. We had one client where their energy costs were going really high. We started going in, looking at the systems. One of the first things we discovered was that the operators in the building had turned everything off of the auto settings into manual. And they were basically running it like they had a multi-million-dollar control system, and they were running it like it was a bunch of analog switches, because they wanted to be in control of turning things on and off. And so we have to re-educate and help the customers understand what that means. But it's also as silly as I have seen a picture, and this was pre-telemetry days, but I saw a piece of pipe come in, supply and return pipe, going through a wall, and on the other side of the wall, it got hooked up backwards.
Oh, jeez.
And so the entire flow of the system was backwards. And that's, you don't have to look very far to find those stories in this industry. They're everywhere. And it's not necessarily because of horrible quality. It's just you're dealing with a very complex system, thousands of feet of pipe, all this different equipment, and mistakes happen. But the difference is, when you make a mistake, do you find it, fix it, and give the customer what they bought? Or does the customer struggle through, sometimes years of trying to figure out why their systems don't perform well?
Yeah.
And then spend a bunch of money on trying to make things work better, only to find out it was some silly thing like a valve was piped backwards, or somebody forgot to put a balancing valve in the right place, and here the whole system doesn't perform.
Yeah, so telemetry really helps to kind of verify some of those issues and have.
Yeah, and it's not just about performance; it's also about efficiency, right? So there's the energy side of the equation. So the building is doing what it is supposed to do, but how well are we doing it?
And I'm glad you said that, Michel, because one of my favorite analogies that he used, and I used this with a client recently, and they accused me of bugging their office because they said they had this exact discussion that morning. But I did not bug their office. I did not know. But I use the example a lot of times, an air handling unit, right? Mechanical systems are notoriously built to be robust. Engineers are very conservative, risk-averse people. So they oversize, they build in extra capacity to systems so that they know that they can handle the bandwidth, the up and down and the increase or decrease in usage in the space. And so systems are really robust. And so let's say you have a system where there's an outdoor air damper, just the linkage breaks and it gets stuck open. And it's the middle of winter and you're bringing in all of this air and all of a sudden you're heating it, but the heating coil and the valve is big enough, so you heat it up. So the unit's maintaining 55-degree discharge air. Mm-hmm. And so the people in the space have no idea that there's anything wrong. Mm-hmm. There's no alarm from the building automation system because you're maintaining the critical factors, the KPIs, if you will, how the system works. And then the utility bill's being paid by somebody in accounts payable. And unless you actually have a proactive energy program, nobody looks at the utility bill. Nobody noticed that the energy bill suddenly went up by a few $1,000s one month and has stayed there for months on end until somebody comes in and does an audit and figures it out. The same thing could be said of, valves. Like sometimes you do simultaneously heating and cooling. Again, it's middle of winter and your cooling valve fails and you're cooling the air and then you're reheating the air. So you're cooling it, you're heating it. Nobody knows the difference. Discharge air temperature stays the same. Duct static air pressure stays the same. The space is comfortable, so the people in the space don't think there's a problem. Right. And it's a very hard problem to see. The utility bill keeps getting paid by payables. They just keep writing a check to the energy company every month. And then one day, several years down the road, somebody comes in and they do an energy audit and they say, oh my gosh, you guys are using twice as many kBTU per square foot per year as everybody else. And you have an Energy Star portfolio score of a 14 out of 100. And they're like, well, how can that be? And then they go back and they find it and like, oh my gosh, how did we not know this? Mm-hmm. Well, they didn't know it because they weren't looking at the data that the building was telling them, but nobody noticed.
Yeah.
When you think about vision and purpose, we are a relatively large company, we're a mid-market company, but in the grand scheme of things, we're a small player when you look at the world overall. And we ask ourselves sometimes, what can we do for the environment? Well, that's one thing actually that when we can partner with our customers, where we can have an impact. I mean, actually, we can save energy. We can make those buildings more efficient, and I find that very rewarding. Yeah. Because this goes beyond the business. It gives us a higher purpose.
Yeah, definitely. Do you think customers are ready for telemetry in this industry?
That is a great question. Some customers are ready for it. I think some customers don't understand. They think, well, I have a building automation system, so what are you guys going to do that's different than that?
Right. Yeah.
And it's hard, right? And so we have to work hard to educate our own business development and sales teams to be able to articulate that message well to the customers. At the same time, we have to help educate the customers and challenge them to say, gosh, your building's really not working as well as you'd like. And for our solution consultants, I think of, you go out and you meet with a customer and you make a first appointment and then you do a survey, and maybe you use building advice and we find some things that look a little weird and we get the energy benchmark and we go, oh, gosh, they're in the 40th percentile in Energy Star. So now we know the equipment doesn't look real good and we know that the energy's a little heavy. And we start looking and they're spending a lot on repairs. So we're trying to build a picture and help educate the customer. Mm-hmm. This takes it to a whole different level of saying, we're not only going to be able to fix it, we can track whether or not we're really making a difference. We can show you your equipment scores at the beginning. We can show you what happens to those equipment scores long term. Mm-hmm. We can get ahead of certain issues that are happening in the building. And as we keep developing telemetry, we'll continue to develop those advanced algorithms or machine learning impacts that'll help us optimize. When should we be changing air filters? When should we be, changing belts? When should we be doing maintenance? Eventually, we'll get there. Right now, we're really focused on building scores and helping people optimize the performance of their systems. And as we bring more and more buildings online, we get more and more points of data. hundreds of millions of points of data right now in our database, we can begin to actually do that advanced work that our data scientist on our team, who leads the telemetry group, can really dig into and start going, how do we combine the energy data, the data from the machines, as well as the information from our field personnel who are out there, who are the real experts? How do we combine those three things together and help our customers really change the way they're doing this? But it's hard for customers to understand that that's such a dramatic difference. Because usually most customers, a lot of times the people who make decisions about facilities aren't even facilities professionals. In big buildings, sure they are. There's smart people who really know their stuff. But in smaller and mid-sized buildings, a lot of times taking care of the service agreements for HVAC or building automation or the janitorial contracts and the landscape contracts, that goes to maybe it's somebody in finance, maybe it's somebody in human resources. In a small company, it might just be whoever raised their hand and said, oh, sure, I'll go ahead and do that. Mm-hmm. And they may not have any expertise. And so they're just looking for the lowest price. Right? They want to say, how do I get this done the cheapest?
Right.
And it's our job to help them understand that we can give them the cheapest overall solution, but it might not be the lowest first price.
Right.
Yeah, I have a slightly different take on this one. I mean, we are a very traditional industry, real estate and construction. It is structured on building codes and a lot of traditions, and things are done a certain way. This technology is disruptive, so it is introducing change that people will resist, because it's just the type of industry we are. So I don't think anybody's ever ready for any change in construction in general. You have to work very hard at it. And then if you look at the question, is a customer ready? It also brings another question: who is the customer? And when you look at that landscape, you have a lot of people that you could call customers that get involved in the decision making. The building owner or the company that is operating the building. It could be the engineering firm that designed the building, or it could be the end user. And especially on this last group, actually, I believe they are ready. We now live in a world where everything is immediate, instant. You get all the data. You want to be able to do something with that data, influence that data, and this brings it. So I would say we have a large population of customers that are definitely ready for it. They're not necessarily the biggest influencers, depending on the situation, on how decisions are made in their organizations, but eventually you get there. If you take a medical facility and the nurses and surgeons are not comfortable, or they're not getting what they need to do their job properly, eventually it will work its way up the system, and they want that control. And if we give them that control, they will influence the people that make decisions or financial decisions in their organizations to get what they want. So I think my answer would be yes, they are ready.
Yeah. How would you say a telemetry-enabled service agreement is different from a traditional service agreement?
It's really outcome-based functionality. So in a traditional service agreement, you have a schedule, you have your specific task planned, and you're going to do maintenance. Traditionally in our industry, it would be a quarterly maintenance program. You're going to change filters, you're going to clean, align, calibrate, tighten, adjust, lubricate. You're going to do all these things that we would normally do for our customers under any circumstance. The difference is that a telemetry-enabled service agreement, you're still going to be doing some of those time interval tasks, but you're also going to be looking at how the building responds and performs, and you're going to be modifying those tasks so that you can optimize the building performance. Our goal is really to take those equipment and ultimately the sum of those equipment, the building scores, and manage those so we maintain a very high level of operational energy efficiency in the building.
Okay, great. Why is Harris in the best position to deliver this type of a service?
Well, there are multiple answers to that. One reason is that when you look at what we do, so we provide the full scope of mechanical services that a mechanical contractor can offer. So we will design, we will build, we will program, how the different systems and pieces of equipment are supposed to operate, and then we will service the building. So we stay with it, so we can actually make sure it does what it is supposed to do. So you get that full cycle. The design component is actually very important. And when I say design, we have multiple levels of design. So the mechanical engineering, but then how everything gets routed, how do you program everything, and even how you design and program the controls in the building. So we manage. We have all that data. We can control the entire product and the entire cycle. So we're in a good position to actually, once we get the data, understand what is really going on and what should we do and how can we better serve the customer. So that's one answer. Another one is the Harris team. We do have fantastic people, and they get it, they understand it, and they can be there, at every step of the way, holding the hand of the customer. So that's those are the top two that come to mind.
Yeah. So with that being said, what challenges do you see with telemetry, both internally and externally?
Well, I think Michel said it earlier, it's a disruptive technology. Mm-hmm. And anytime you have a disruptive technology, you do run into the challenge, both internally and externally, of getting people to change the way they've been doing it for a long time. So people have a proven process, they know it works. Asking them to change can always be difficult. It's not simple. Most people are willing to give it a try, but it takes time. And it's an evolution as you disrupt the industry, and getting everybody from our internal teams, from salespeople who are used to doing things one way, and getting them to present a new product a different way, to the operations team that have to deliver the services and follow up. And then the customers have to be open to saying, yeah, there is a better way to do this. And so it's time. We have to continue to prove ourselves every single day and deliver the results that we say. And as we go, it becomes easier and easier because people start to realize that it really does work, and the disruption is worth the change. The change is worth the benefit on the back end. Right.
Michel, what would you say?
Well, the other thing I would add is that it is an evolution also from being, for the industry being purely a construction trade, and in our case, a mechanical contractor, and now starting to become a technology company. And that's a big shift. And that may be a cliche in when we see what is going on in the world right now. But for us, it's a reality. So all of a sudden, it's not just going into a building and dialing a valve up and down and trying a few things. Now we actually are getting the data. We build models. We are getting towards intelligence in the process, and actually maybe at a point where we'll start anticipating building behavior and doing things before they happen for the best interest of the customer, and that is different. This is not something that a traditional construction company was even thinking about 10 years ago or 20 years ago, and here we are doing it, and that's a complex change, and but it's exciting at the same time. Right?
Yeah. So Bob, how can telemetry bring our service, building automation, and construction teams all together?
I think it's a bit of what we've been talking about a little bit. We've touched on it multiple times, both Michel and I, but it's that at Harris, we envision ourselves being involved with the customer from the beginning of their design of their system with our Harris Design Studio. We have great engineers. We have the ability to design, to build, to help them operate, maintain, repair, and then long-term retrofit their systems, because the buildings, it starts in year zero, but 20 years down the road, those systems are still there. Those are fixed assets. They don't go away. They don't get taken, in a complex building, their air handlers could be there for 40 or 50 years. Right. And so we want to be with the customer the entire step of the way. And so it really brings our vision of being that trusted partner from the beginning of the process all the way to the time when they decide to remove and replace their systems. And then we're there to start the process all over again with our design studio, who can help them figure out the best way to retrofit their building. And then we'll continue to operate and maintain and control and do all the things we need to do.
Yeah, sure.
Yeah, I think it still aligns with the trust I was talking about earlier, especially for the construction and controls side of things, that you do get certainty. It is actually doing what it is supposed to do. If by any chance something was installed or maybe even designed slightly off, you will catch it, you will change it, and you will still deliver the value that the customer is looking for. And when you look at the complexity of buildings, and we're not always in control of the entire process. It does happen very often that we are working on an addition to an existing building. So somebody did something on the other part of the building 20 years ago. There aren't any drawings. There's not a 3D model that tells us what it does. And now we have to connect to that. And now we have to deliver perfection on the part that we are doing. Some things require adjustments, and that technology actually gives us more tools to be able to do that, and that's kind of fun.
Yeah. Well, we've talked about a lot today with telemetry. I would love to know what both of your elevator pitch would be when it comes to telemetry. Bob, I'll let you go first.
Gee, thanks. My elevator pitch really doesn't change from the same one I've used forever, and that's assuming the old mantra that you get on the elevator and one of your target clients is standing on there, and they look at you and they say, "Oh, you're with Harris. What does Harris do?" I've always said the same thing for the last 30 years. We help you do what you do better, and usually that response gets them to say, "Well, how do you know what I do?" Or, "Well, now's your chance to tell me. What do you do?"
Yeah.
And they can tell you, because in reality, what we're doing is we're supporting critical infrastructure for our customers. So the customer's job, sometimes people get mad and I say, customers don't really care about their HVAC maintenance program, or they don't care what kind of chiller they have. I mean, 90% of the customers I've met don't give any care at all over whether they have York or Carrier or Trane chillers, or what kind of air handling units they have, or even which building automation system they have. I mean, there's some notable exceptions, but most people just don't care. They're there to do something with their business. And if their business makes, motorcycle parts, they want to make the best motorcycle part known to mankind. And the critical infrastructure, our job is to enable them to do what they do better. So we create the right space, the right temperature. We do it efficiently at the lowest possible overall cost to them. And that allows them to run their business better and take care of their customers, because they really don't worry about us. They worry about their customers and whether their customers are happy. So in the end, we help them do what they do better. Yeah. And that's what I've always used, that just because I found it to be the simplest thing to explain what do you do in this business.
Yeah, it's a great one. I'm gonna have to use that. Michel?
Well, I hope the elevator was going up 100 stories, because that was a long one. With telemetry, your building will do what it's supposed to do. I guarantee it. That's it.
There you go. That's a great one. Well, thank you both so much for joining me today. I hope everyone enjoyed listening in on this very first podcast. Until next time, I'm Tiffany with Tiffany Talks Telemetry.